Hi everyone, and welcome to this new episode of Revit Programming using Python. And today we're going to use these grids to create columns in each intersection between each of these grids. So let's start. So first of all, I'm going to start by selecting the grids in this view and then open the Revit Python shell. Okay, so the first thing that we need to do is to set the selection as an S variable. Now, what am I going to do is to write a code to find the grids that are horizontal and the grids that are vertical. As you can see, the vertical ones are named by numbers and the horizontal ones are letters. So let's see what can we do about this. So let's set a list for grids with numbers and list for grids with the alphabet. So let's say grids. Let's call them num and make a empty list, and another one grids. Let's call it elf, another list. So now let's say if, or let's say for I in S, which is the selection. So for each grid inside this selection, if I is what we can do here is digit. So is digit is a number basically. So or no, before we do that, it's basically we need the name. So if the name is a digit, it's a number, we are going to add it to this grid number list. So if this is true, I dot append, not I basically, it's the grids. So I'm going to add the I in this case to the first list. Else, if this is not true, then grids elf this time dot append I. So if the name is a number, it's going to add the grid to the first list. If the name is um, is not a number, basically, it's going to add it to the second list. So let's see now if we print the first list, what do we have? So as you can see, we have how many items in here? So we have 1, 2, 3, 4, 5, and 6. Exactly. So we have 6 items. So you can check this really quickly by typing for I in number grid, for example, print I dot name to make sure everything is going all right. So if we do this, as you can see, we can get the names, and if we change to check also the second one, you're going to get A, B, C, D, these ones. Okay, so now that we have the horizontal and the vertical grids, basically what we can do is get the intersection. And how to do this? Let's go to the Revit API and just type intersection method. Okay, so we're gonna use this one. So this one is in the curve class. Okay, so basically for each curve we need to get the for each grid we need to get the curve, and then we are going to apply this this method on them. So let's go back to the Revit Python shell, and here what can we do really quickly is to add them as curves. So basically I'm not sure if we can do this or not. Let's see what do we get. This is or not. Okay, so we got the lines, and if we check the other one also, great. So now we have them as curves. So they are not, they are no longer grids inside the lists. I have curves now. Now let's use this method. So what we're going to do is basically type in a curve dot intersect, and inside the other curve that we wanted to intersect with, and then the intersection result array. So the intersection result array, let's start with it. So I'm going to type result. So this should be an array. Let's click on it. Yeah. So this should be an array, and it should be a strong box. So if you don't use the strong box array, you're going to get an error. And in the previous video we talked about this. So let's just type strong box and then open two brackets, and inside them copy this line and print it inside, and then there is an array in here. So this is the second argument that we're going to pass, and we are going to see in a second what does this do. So now we don't have one curve with another curve to intersect, we have many. So we are going to create a for loop. So let's say for I in, so here there are no longer grids. Okay, so let's leave them as grids. So let's say grids num, and inside I'm going to add another loop. Let's call it J. For in grids health. And what do we want to do? We want to set an intersection. So just going to call it Y. And this is basically I dot intersect. Okay. And open the bracket. It's going to intersect with each J, which is a line from the other list, dot the second argument, which is result. Okay, so let's see what do we have so far. Oh, basically here is not a dot, this is another argument, so just a comma. So let's print Y to see what do we have so far. So as you can see, we have overlap, 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 and then disjoint, disjoint, overlap. So basically, the overlap is when we have a grid intersecting with another grid. Okay, this is called overlap. And this is disjoint. So this line is disjoint from this other one. They're not overlapping. So we don't need this. We don't want to create columns here. We just want to create them on the overlapping lines. So what can we do about this? So first of all, let me create a list for intersections. Let's call it inter LST. This is a empty list. And what am I going to do is to set a logic in here. So let's say if y is equal to just a second. Yeah. So this is called set comparison. So basically the methods of set comparison, you can find them if you click on there. You can find overlap, disjoint, and so on. So I'm going to check if this set comparison result, let me go back here. If this is overlap, okay, then what is going to happen is basically, let's call them intersection points, PT, is going to be result dot get item 0 dot xyz point. So what is this? If you go to the result of the array, I think we can find it in here. Intersection array, I believe. Oh, this is it. So if we click on this intersection result on members, so the intersection result has properties, as you can see here, xyz point, and this is what we need. We need them as points. So what are we going to do in here? If this is overlapping, then the result get me the item, and this item, I want it to be an XYZ point. I want it to be this type of data, okay? So we need them as points. I hope this is clear, okay? So now I believe if we print this, okay, object has no attribute get item. Okay, this is because this should be a capital letter. So as you can see now, I have my points, and as you can see, the Z is 0 because we are on level with the elevation set to 0. Okay, so now I have all my points. What should I do next is to add them to this intersection intersection list. So let's append them to the list. I just call it enter p e. All right, so now that we have our points, we can go to our main our main goal is to create columns. So let's go to the yes, creation namespace, document, members, and scroll down to find, yes, we're going to use this one. So we're going to create new family instance with XYZ point because it's a column. And we need a family symbol, we need a level, and we need a structural type. So the XYZ, we have them. The structural type, so let's just click. The structural type is basically these that you see in here. And to use them, you have to type structure dot structural type dot one of these members. We need a column. All right. And the two other arguments are the family symbol and the level. The appropriate way to do that is, I believe, to filter the elements and find the family types according to if it is the family symbol. You type if this is the name that you want, so you get it from the filter, and the level you can filter them using the name or the elevation, for example. So we're not going to do it that way. We're just going with the lazy way. Okay, so back to the Revit Python shell. I imported the libraries that I'm going to use in here, and of course the transaction, the document. I added the level variable and assigned it to get element using the ID as I said. Same thing for the column symbol. And then, so I think we are ready to go. Okay, so here it was enter LST, enter point, all right. Oh, and then we opened the transaction and I typed for P in intersection list, which has all my intersection points. Sorry. So here is the method that we talked about to create new family instance. So it's doc for me is the Revit activate UI document. Dot create dot new family instance, and the argument, the first one is the point from the list, and then the column symbol, and then the level, and then structure dot structural type dot column. So if we hit run now, as you can see, the columns are placed at the intersecting points exactly as we wanted them. So I hope this was useful. Thanks for watching and see you next time.